Hey, what's going on, folks? It's Mike here, and welcome back to my Modern C++ series. In today's episode, we're going to be revisiting the idea of casting, but this time taking control with user-defined casting or conversion functions. So this is another type of sort of operator overload that you can think of, but it gives you control over what happens if you want to convert one type to another. So let's go ahead and review a little bit with casting, which we've talked about previously in this series, so you can check out those videos. But again, just to give us a little bit of a refresher and talk about something new here. So let's go ahead and dive over to cppreference.com here. And I'm going to be under the language section here, and you'll find here under conversions exactly what we're going to be talking about with the user-defined conversions here. So user-defined conversion makes it possible to specify conversion from user-defined classes. Okay, so I'm going to go ahead and click on this, but let's just do a little bit of a review here with conversion functions here. And basically when I say I'm converting something, it's treating one data type as another data type here. So let's go ahead and just say I have some double float value here. Let's just pick some random number here. And let's go ahead and say that we want to convert this type here into a integer type here. Okay, so a little quick refresher here. I'm going to go ahead and compile this with C++23 here. Output the program and compile it and run it. And, well, if I treat this as an integer, it, of course, is going to truncate it. Okay, so for the primitive types, things like doubles, integers, characters, etc., right, we can just use these casts here. Now, typically in modern C++, we also like to, if you remember, use some of the more explicit casts here. So we can search for them in our code here. So something like a static cast might be more appropriate in this case here. Static, again, being able to sort of determine at compile time if this is valid. We have dynamic cast here. Let's just go ahead and use it. But this typically is used for, well, if it's a pointer or a reference. So usually when we have some sort of polymorphic behavior here, right, for inheritance. So it's not going to really work on our primitive types here, but just wanted to remind you of that here. And then we have reinterpret cast, the hardest one to spell. There we go. Which, again, is going to say, at least if the types sort of match. Let's go ahead and see if we make this like a long or something here. Long. It still won't let us convert here, but reinterpret cast is basically like a, hey, trust me, I promise, you know, this data type is what I say it is. And you actually get some additional type checking, which is nice to see here. But again, typically these are when you have like pointers to bytes or something, and you want to just say, hey, treat these like 8 bits as, you know, this type or something. So anyways, the common one that you'll see still is this. The common one we should be using is typically this. This is the right example for this one here. Whoops, just got to make sure I have all my parentheses, though, so that we compile. There we go. And that's just a little reminder on casts here. Now, what becomes interesting, though, is when you have your own user-defined type here. Okay, so let's go ahead and I'm just going to go ahead and comment out this example here, but you can kind of remember it here. This is our reminder on casting here about where these sort of conversions happen. And the immediate thing that I could think of here is, like, let's say I have a struct, like a pair, for instance. And let's say I've got it something defined like this. And then let's say I have another struct like a triple, something like this here. Okay, I'm going to define it just slightly differently here. 3 values here. But I want to be able to convert from these two here, right? And maybe, again, just to make this a concrete example, how you might think about this in like game programming or something here, right? This is my like vec2 type, and this is my, vec3 type here, okay? Now, it might be called triple, pair, quadruple, or whatever, if it's a vec4, whatever. But this is, again, just an example here. And depending on how we define these types here, right, the layout might not exactly match. I mean, this is going to, like, overlap. But, again, it's not obvious that these are 2 separate variables versus a contiguous chunk of memory. So, again, there's a little bit of differences here where we might want to define our own sort of conversion here. Now, what can I do here to make this work here? So what I wanted to go ahead and do here, let's just create a triple T here. And just for brevity here, I'm just going to set the values. Let's set one value to that here. And normally I wouldn't set these on the same line here, but I just want us to save a little bit of space here in case our example gets a little bit long here. But something like this here. Okay. So the first value will be 1.1, the second value will be 2.2, and the third value will be 3.3 in these values here for our triple here. Okay, and what I want to be able to do here is construct let's say a pair from this triple, because sometimes I just don't need all three values, right? And this happens sometimes in graphics programming where you have a 4-dimensional vector and you need to go to 3 dimensions, or 3 dimensions and go down to 2, right? Right. So you could just effectively chop off what would be the third component here and only use X and Z here. Okay, so what are our options here to do this? So basically what I'm saying here is, how am I able to do something like pair P equals T, or I want to write out, for instance, let's say I have some pair already, P, and I want to treat it T as a pair here, okay? So let's see, if I try to compile this here, what am I going to get here? Oh, one compile error. I always forget my semicolons here. But I'm going to get this error: conversion from triple to non-scalar pair required. And this is going to say, cannot convert triple to, I mean, I guess it's just guessing float, because that's the first field here, which is also equally confusing, right? I mean, the error message is kind of tripping up, right? A struct is really just a convenience thing for us, right? Really, this struct is just 3 floats anyways, in a contiguous chunk of memory. So what can I do here? Well, you know, this type of conversion I should be able to do here. If in my triple here, for instance, I provide a copy, or you could just say constructor, right? Let's just say constructor here. That takes in a pair, and let's do it properly. Let's take it by reference, and it's gonna be const because we don't want it to change here. And I would just say t.values of 0 equals p.x, and the next thing would be next element would be the wife element here. And oops, sorry, I don't need a t here. There we go. But let's see, does that get us anything here? Okay, well, now we have this issue with our triple here. So let's define a regular constructor here. See, I told you this would get a little bit long here, just to make sure that we have it here. Okay, it's still saying conversion from triple to non-scalar type requested here. And again, we got to be careful here. Maybe we want, here, let's just fix this up a little bit here. Let's create our pair, and let's give ourselves something just to play with here. P.x equals 10.10, P.y equals 11.11. And I'm just giving myself some different values here. Okay, and let's actually try the opposite here, where we go from our triple, or t rather, equals, I want to treat this as a pair here, something like that here. Or let's do a new triple t2 equals p, something like that here, okay? Now this is actually possible here. Now that I've defined it in the right order, right? This is going to call the constructor, and this is going to do the, well, the conversion for us here. So let's go ahead and see here. Let's see. Let's just go ahead and write out constructor. Here we are. And let's just go ahead and call it triple here. Okay. Triple, triple. Something like that here. Let's see where it was called. It's called twice, right? One here. Or, let's go ahead and see. Because, well, I mean, we have a few constructors being called here, but let's just go ahead and define the triple pair constructor. And then we should probably put in here the regular triple constructor. Just because we have one called here, right? So, so we have our first constructor that's called here, and then, these two guys are being called here. Okay, and we're doing this kind of efficiently and so on. But now that we sort of have our working example, let's go ahead and take a look at these user-defined conversions here. Okay, so conversion function is declared like a non-static member function or member function template, et cetera, et cetera. And I mean, what's kind of interesting here is when we're calling these, like, I'm doing a constructor for t equals p. I mean, that's kind of a weird thing, right? I'm just doing this assignment here. It's saying, yeah, that's allowed, but this is kind of the best thing that the compiler was able to find here. Let's push this a little bit further here. Let's see if I can do standard cout. Again, we're just going to be playing here. And the thing that I'm trying to do here is be able to get out of a, convert a triple to a pair or vice versa here. So let's go ahead and say I have a pair here. I want to treat my triple here. I'm going to wrap these in parentheses here. But again, what I'm doing here is, again, my triple accesses things through values, but I'm saying, hey, cast it as a pair so I can, do .x or whatever, because that seems, convenient for whatever reason, and I don't need the third dimension here. Can I do this? Okay. This I can't do, apparently. Okay, and I think I've counted my parentheses correct here, so no mistakes here. So this isn't allowed. But I am getting these, sort of conversions here, which is kind of interesting. It's using the constructor. So let's see if I'm still getting 3 constructors, basically, if I define this conversion here. And then if I'm able to do this cast here, if I define the operator here. Okay, just so we can kind of keep straight the constructors and conversion functions and so on. Okay, so basically what I'm going to do here is define this operator here. Explicit, remember, means that, it's not, the compiler is not going to guess or try to resolve things. It's only going to say, hey, I explicitly want this type to that type here. So we're going to remind ourselves about that here. And that's the basic idea here, right? So again, here's our struct here, which in this case you can replace with triple here, and we want to convert the operator into a pair here, and then we'll say what to return or how to do the conversion here, okay? From one type to another. I mean, this might involve like actually just returning a pair here, so that you could do the actual conversion or whatever. But again, let's go ahead and play around with this here. So let's go ahead and define then our operator, the thing that we want to return, pair, and I'll do const. And let's go ahead and let's just go ahead and compile this. Let's say, okay, no return type. I mean, this is the thing. I need to return some sort of valid pair here. Now, to make our life a little bit easier, let's give ourselves a pair constructor that takes in a x and a y. And let's go ahead and just say x, just to remember a little bit of our C++, and have a list initialization here. Let's go ahead and do that. Okay, just so we can also get it in one line here. Okay. Let's see here. What else did I miss here? Oh, I think that looks okay here. But now we need to get our pair constructed properly. 10.10f, 11.11f. So you can see I have to play around with this a little bit here. But it did make our code more concise. And now I can just return this pair here. And, well, how do I want to treat this as... let's go ahead and look down here at our goal. We want to treat our triple as a pair. So what am I returning here? Well, again, it is a triple, so I'm using these values here. And actually, let me pause this for a second here. I mean, it's interesting that this will actually compile and give us the warning with the return statement. Then you get a illegal instruction. So this could be one of the cases if you ever see this illegal instruction that you have like some weird, unfinished conversion or maybe some implicit cast here. So just keep an eye on that. So anyway, let's return our conversion function here. Oops, and well, still gotta add the return keyword here. We can't just construct this thing. There we go. And now it's working here, okay? Looks like we're still constructing 3 things here, which is kind of interesting. But we are able to now do our conversion here, okay? Okay, so let's try a few more things here, just to, again, play around with it. So, again, if I have this constructor here, this is fine here. But let's use that word explicit here, okay? Let's go ahead and put it on our constructor here, explicit, okay? And then, ooh, all of a sudden, I mean, I get this nice catch here where it's like, yeah, I don't know if I should have just automatically converted that, right? Because we didn't assign a operator equal thing to tell us how to do this conversion here. So yeah, that's not going to be allowed here. So typically, you kind of want your constructors to be explicit, like you explicitly called for this thing to be created here. So again, just kind of digging through the error messages, you're going to see, okay, no known conversion for one argument from pair to const triple here, because again, we have to be explicit here. It gives us this candidate here, right? This is sort of the default, stuff that was generated by the compiler here, right? The compiler is always making like move assignment and stuff here, but again, we've got this as explicit here, which it will try to use here. Then we're getting an error at line 34, which says conversion from pair to non-scalar type requested here. So again, this isn't allowed for us. So, I mean, we've sort of restricted ourselves, but again, usually you want to do the sort of explicit thing here. Okay. Let's go ahead and play around with this. Let's get rid of this constructor here and just leave our conversion operator here. If we do this again, so we're going to have the same, and again, let's double triple check that we saved here. Same sort of issue here. No match here. For this sort of behavior here, right? We've got to define exactly how to handle pairs here. It's not going to call this operator thing here. And again, this sort of conversion from pair to non-scalar type triple isn't going to work either. Okay, now what if we go the opposite way here? Now that we've defined this conversion function, and I do pair. Actually, let's hold on to this here, just so again we have everything in one place here. But can I go from pair, I don't know, p2 equals t here, something like this here, and we got to comment out some of this stuff here. Okay, just for our conversions here, and this is okay. Well, let's actually print out these fields now. Cout p2.x. I'm going to do a comma here, p2.y, and let's just do an end line here. Let's run it. And lo and behold, p2 is getting our triple values here, okay? Because, again, we have this conversion operator defined for us here, okay? And it's not doing any, like, weird magic or anything here. Like, let's go ahead and just say we have a bool x here or something. Right, it's still doing the same thing, even if we're changing the layout, okay? Just, again, to prove to ourselves, or prove to myself that that's working. So, we can go in this direction here now that we know how to treat a pair and a triple together here, okay? Let's do one other thing here. Again, just to play around with explicit, and I'll go ahead and try to compile this, and now it's going to say, yeah, no, you're not allowed to do this because, right, this was the, kind of we're fooling around and doing overload resolution here, and eventually we can find if we don't have, the default copy constructor that works right, or assignment operator or whatever, that, you can't just fall back to this conversion here and construct a pair from a triple here. Okay, so it's thinking a little bit in reverse here. So again, probably want explicit there to do so. Okay, and let's go ahead and say if we have, again, from this pair here, and I want to say, or rather treat, again, our triple T here. Let's just cast it. I'm going to wrap it in two parentheses here. And treat it with an X, another comma here, and then I can do the same thing here, pair t.y, and end line. We should get the same result. Oops, I marked it as explicit still. Right, so yeah, this, there we go. Let's just get rid of that for a moment. We've got to make sure all of our parentheses line up here with our stream operators. Maybe I should have used print for this example. Maybe I'll use it in another one. But this works here, okay? With or without the explicit, this will work here, okay? So no problem there. Let's see here. But, I would say if you're going to use this type of casting here, it's a good way to capture errors or catch things if you always mark explicit here, right? So we don't have like magic conversions happening otherwise. So basically anywhere that you use cast, this is kind of wrapping up the video here, from one type to another. we can handle this situation here, okay, without going to like constructors or, you know, copy constructors or other sorts of magic happening here, okay? We know exactly what to do. In this case, it's to return the pair with the values here, which is constructing a new type here. You might want to do something else like just return one value. You might want to throw an error and say, hey, this is dangerous, don't do this. I mean, whatever you sort of decide here if you want to capture these sort of casts here. As you can tell, this is sort of a foot gun in the language in some ways that, you know, you have these sort of scenarios here where you're, you know, maybe getting this behavior that you may or may not expect here. Again, let's go ahead and run it here. But again, that's why you should start to see, or in your code base, if you want to sort of harden it, more explicit operations, just so you can know what's happening. And then you know exactly what operation's being called here. Let me see if there's anything else interesting in this example here. Let's see, they got their struct x, and they define the conversion to an int type here. Okay, and then they have their int equals, let's see, whatever this thing, x that they're casting into an integer. So again, what was the equivalent thing that we were doing? We defined our type triple, and then we said, hey, we know how to convert this into a pair. Which is what we did here. We said, hey, I have this thing triple, and I know how to convert it to a pair here, okay? And we try to go the opposite direction here. Let's see here, like this here. I gotta get rid of this explicit here. Let's get rid of this here. Okay. And this was also okay. Let's uncomment all of this when we had the copy constructor, or rather the constructor defined here. All right, so it's not gonna like that. And let's go ahead and give this here. And again, let's do our little experiment here. I might need to get rid of that explicit here. Yep. Just for all those t equals p's that it doesn't like here. And we could see, again, just matching up our constructors here, that this is the default constructor. This is the copy constructor. So first default constructor, second copy constructor that's called, and this is the other copy constructor that is called here. And then we have all of our conversions here. Okay, let's get rid of our operator thingy here. Then it's just gonna yell at us. I guess enough here. So we can't do that here. But then we're gonna get the pair operation called here. So again, in my mind, the thing that the operator gets us is, one, you get the advantage of calling explicit here, okay, which is usually what we want for the conversion here. And this is blocking us out at line 38 here, because the overload resolution rules are otherwise saying, hey, we're getting confused how to do this conversion here. I think if I make it not explicit, then you can actually do this. But again, it is getting confused here. And if I get rid of the operator stuff here, again, it will get confused here. Okay, so now you have a way to go from a pair to a triple on assignment, or a triple to a pair by calling the copy constructor. But if you want to treat a pair here as a triple and instantiate it, right, you need this conversion operator to be able to do this. Other things that you could do is, of course, in your pair, you could define a copy constructor or a constructor that just takes in a triple and drops out. But again, that's, I mean, you really want this conversion operation to say what happened, I guess, when you're using casting. If you're constructing a new type, that's fine. But if you're using it like this here, which we are here, right, just doing the cast, that's probably what you want to do here, right? Just temporarily, construct a new object that's a copy of the other type here, the triple here. So let me perhaps wrap this up with another link here that I'm going to bring in. I should start bringing these in more, but Yeah, this is all to say that in the C++ core guidelines, you want to avoid implicit conversion operators. So let's go ahead and follow our rule here. Let's make this explicit, right? All of our conversions. And then we could say, and let's make our constructors explicit. And we can see, oh, we've got all these, issues here, right? Where, we don't want to do these sort of hidden conversions here. Okay, let's get rid of all of them now. Let's make this proper code here. Line 42 here. Yeah, we want to be explicit here. How could I do this? Well, let's say if I, can I cast it here? Let's say if I was explicit in that way, will it be satisfied? Okay, that'll be satisfied there. And here, I want to treat this as a pair. Now it's satisfied here. I was explicit, okay? And let's use our good C++ here. C++ 11 here with the static cast here. Here we go. And here we go here. Let's cast this as a pair. There we go. Now we are happy in our world here. So sorry, that was a long way to basically just say that let's basically make everything explicit as much as possible here, because then you know exactly what the conversion is and what is being called here. And you could also see here where I did this. Let's see here. Let's put this one back here. Let's see. Is this going to complain at us? Yes, it is going to complain to us. Static cast here to a triple, our pair. And then, we still have our copy constructors being called here. But then for all of our casts, we are doing the explicit operation here. And we can capture them, we can log them, etc. So let's just look at that core guideline here just to see if I missed anything. Let's see. Here we go. All right. Avoid. Oh, where is it? Conversion. And this is how I kind of search for this. Avoid conversion operators. Implicit conversions can be essential, for the default types. But yeah, these sort of surprises we don't really like here. Okay, so prefer explicitly named conversions until a serious need is demonstrated. And by serious, let's see. I can't really... I'm trying to think of one if maybe there's one just like super common or something that you'd not want in your code, but that could be the idea here. Okay, and then they just give another example if you don't like the CPP reference one. Okay, so anyways, let's get rid of that. Let's just take a look at our example. Let's try to summarize this. I know I danced around the code a lot here, but the point was we have two types that are kind of related, and we want to be able to convert them, but we don't want to be surprised, right? We don't want a triple to just be converted here. We can have constructors to do part of this work here, and we can also have our operators here when we want to do a cast here. So keep in mind the constructors are related to when you're creating a new type here or doing some sort of maybe assignment here that would create a new type here. And then we have our operator for when we're doing casting here, whether we're doing that by like a static cast or otherwise a better C++ 11 style cast here, which again, I will do static cast here. Oops, pair. And actually, look how that cleans up our code here with all the parentheses. That's kind of nice here. Let's run it again here. It's a little bit more wordy, so it's going to mess up our indentation, but that's okay here. Okay, so let's go ahead and just finish this off here. But again, the whole point was this static cast will say, okay, I know how to treat a triple as a pair, return that pair, and then, give me the .x value of it here, okay? Okay, last thing here. Let's go ahead and say operator pair. And we can see where that's called here. Basically for all of our conversions as we're doing them here, okay? So how many times did we do that here? Well, how many times did we print things out? 1, 2, 3, 4 here. Okay. So now you can also see the cost of, well, converting, right? I'm building this new type here just to print out a value here. Now that's another interesting insight here. So, congratulations to those of you who have stuck around for the whole 30-minute video, as this has been sort of an exploration. But now you can actually see that is kind of interesting to see the cost of casting here, especially when you have other types here. And this is another reason why something like reinterpret cast is kind of interesting, because it just says, hey, treat these bits as some other set of bits here. So it's kind of the fast thing to do, perhaps, but the unsafe thing to do. And this is the safe thing to do, but maybe at the cost of like, hey, we had to create this new pair type and get rid of a bunch of stuff, but I just needed to print out .x here, okay? So anyways, a few different things to think about. If you're converting between data a lot, there is a cost. And the proper way to do it, as I'll reiterate, is to try to use explicit where possible so you have less surprises in your C++ code. Alrighty, folks, so for this lesson, all the other lessons on casting, check out courses.msha.io. I particularly don't like casting a lot because of, one, the hidden costs. You can see it's a little bit confusing sometimes trying to figure out, is the constructor being called or the operator. But anyways, all those lessons and more are here for you to follow along with. And let me know what your thoughts are. Do you have other hard and fast rules? Do you mostly make your constructors and conversion operators explicit already? Has that helped your code base? These would be really interesting things. It's not the most exciting topic in some sense, but it is useful to know about that it exists and where it applies and the costs of casting. Alrighty, folks. So anyways, hopefully you enjoyed that lesson. Some of the other ones will be more exciting, but hopefully this otherwise was an interesting exploration and just seeing where stuff happens in the C++ language. Alrighty, folks. I'll go ahead and cut this video here, and we'll see you in the next one.